So today we are going to do one case study. So this case study session we have divided it into two parts. So let's start with the today's case study that we are going to do on the Titanic data set, and we will be importing this data set from the seaborn library itself. Now, this case study is basically to understand the different visualization technique, like whatever we have learned, right, like till yet. So those visualization, apart from that, we will be learning few other visualization techniques also, like pie chart plotting and count plot, how we can do the multiple plots. So those all things we'll be learning, right? So first thing we need to do is we need to import the different libraries or packages. So we'll be importing NumPy as NP, then import pandas as PD, import matplotlib.pyplot as PLT, and import seaborn as SNS. Okay, so this four library we need for this. That's fine. Now we know that in the seaborn we have lots of data sets. So this is the Titanic data set we have. In that, these all are the different columns, and we have around 800 data points. Okay, so total 800 or 800 something data points we have inside this, 892. Okay, so we are going to import this data set and we are going to have a look at it. So first of all, whenever we import any data set, like let me import this Titanic is equal to load underscore data set. This is the method, and we'll be writing the data set name Titanic. And whenever you load the data set, so if you want some basic information that like you just want to analyze the data, like you want to have a just look at the data, like what kind of data it is, what all values you have and all, so you can get it using the we have head function, right? So this will be giving you first 5 rows, Titanic.sns. Load underscore dataset. So this gives you first 5 rows. In that you will be getting the first 5 rows and the different columns, whatever you have got. Let's say if you want to get the any particular information about a column, so you can do that. So let's say here we are getting survived column basically is only the categorical data, and it is having only 2 values, 0 and 1. 0 means not survived, 1 means survived. Passenger class, there are 3 values, 1, 2, and 3. So basically 3 passenger, like there were 3 types of passenger: first class passenger, second class passenger, or third class passenger. Okay. Then we have the sex column that tells that whether male or female passengers were there. Age is the numerical column and fare is the numerical column. Sibling, spouse, and parts, again this is the categorical data. So sibling, spouse, there were some siblings or spouse, and how what was the number, that information we have, and parts with that how many parent-child relations were there. Okay. Embarked is the embarked town code. So from which town people have embarked, so that code that has been given. Class, again, so this class and passenger class are similar. This is the you can say the type for this is, you can say, object, and for this it is numerical. Who, again, so this is man or woman. For, again, sex is similar. Adult male, whether the passenger was adult male or not, so that true and false you have. From which date they have ported, so that information you have. Embarked town, alive, yes or no, and alone, false. So most of the column here you can see that it is the categorical column. So we'll be doing the mainly categorical analysis here. Okay. Yes, we'll be trying to find the count and all also. There is a describe method. Okay. So let's say if you will be using Titanic dot describe. So this describe method basically describes or gives you the information like mean or median or percentile values, like 25 percentile, 50 percentile, or 75 percentile, standard deviation and all. So these values will be provided for the different columns you have, and only for the numerical data. So survived is numerical data, passenger class is numerical data, age is numerical data, sibling, spouse is numerical data. Then you have parts, which is numerical data. Then you have fare, which is numerical data. Rest all are the object data. So we don't have any information for that, but only those columns which are numerical data, we are getting some statistical information over here. count or mean value or the standard deviation or the minimum or different percentile or the maximum value. Okay, fine. So what information we can get here is that minimum value is 0, like sibling spouse, there was 0 sibling spouse, or maximum number was 8. Okay, so 8 sibling spouse might have come. So siblings or spouse, any relation might be there. Past parent child relation, so minimum was 0 and maximum was 6. So 6 people might have come with their parents or with their children. Okay, similarly fair, so the maximum was 512 and minimum was 0. Okay, so there were few people who paid nothing for boarding into the Titanic. Okay, and then you have the different information, the other information, median, mean values, which are the kind of average you can take. Okay, so these all are the different information, and there is one more function, that is Titanic.info. You can say this info function gives you the information about the different column. Okay, so how many null values you have, what is the data type for every column and all, so that you can get. So let's say if I ask you to get the data type of a particular column, how you can get that? So let's say if I ask you to get the data type of survived column, so you can write here Titanic dot survived. Okay, and this will be giving you the survived column, and for that you want to get the D type. Okay, so you can write D type and you will be getting that it is integer column, right? Fine. Now let's say if you want to convert this to the categorical, so you can write dot as, you can write here, let's say categorical. Let me see, categorical, category as type. No, this should be okay. So now if you will be checking the D type for this, so this will be now converted to the categories, and only two values you have, 0, 1, and ordered is equal to false. So there is no particular order we have set into. So basically now using as type function, we have passed here category, and if you'll see what all attributes you can pass in as type. So you have the different values, like you can see as type column 1 int 32. Okay, or you can write here D type is equal to int 32, or as type int 64. So if you want the numerical values, accordingly you can pass the data type, and if you want the categorical, the data to be converted into the categorical, then you can write here category. Okay, so now we have converted this particular data. We have seen this data. Okay, and we have the different column and their types and non-null values. Okay, so what I want to do is basically I want to do a plot of the null values and non-null values using a heat map function. Okay, so basically what I want to see, that in the heat map function, if I'll be plotting this all columns for the survived column, P class or sex or age or sibling spouse, so wherever I have the missing data over here or over here, so it will be giving me a plot, right, that where exactly the data is missing. Okay, so that I can get it using heat map. So basically what I need to do is, first of all, I'll be checking that which all values are null. Okay, so I'll be writing here, let's say to check which all values are null, you have is null function. Okay, and that gives you a Boolean matrix. So whichever value is not null, that will be giving you, null means what, NaN value. You can see it here. Age. Okay, so let me write here 10. If you'll see, you have NaN value here, right? Somewhere else you'll be having NaN value. You can see null value, this two null value, this null value, this null value. So this NaN represents null value. Okay, so wherever we have the null values, that is set to, like NaN value, that is set to true, and wherever we have not null values, that is set to false. Okay, it means if some value is present, that is set to false, and if the value is not present, NaN is present, then it is converted to true. Type of Titanic dot survived. We are getting it as a series type. Okay, and the data inside this is not a categorical data, right? So if you'll see here, when I'm writing, I'm converting this to the, so before this, if I'm writing dot d type, let's say Titanic dot survived dot d type here, dot d type, what it is giving, it is giving me data type for the values inside. This is integer 64. Let's say if I want to find the sum of how many null values we have in the survived column, how many null values we have in the passenger class column, how many null values we have in the sex column, age column, sibling spouse, parts, fare, and so on. So to get the count of null values, we can write the dot sum function. Okay, dot sum, and that will be giving me the count of null values in every column. Okay, so in the age column, we have around 177 null values, and in the date column, we have 688 null values. In the embarked and embarked town, we have 2 null values. So now let's say if I want to do a plot of these null values, I want to visualize that where exactly these missing values are there, on the top in the data set or in the below data set. Okay. So what I can do is I can use sns.heatmap function, sns.heatmap function, and I can pass this is null. Is null data set, okay, which is a true false value, right? This data set I'm passing, and then I will be taking the cmap is equal to, let's say where it is. This is a different color combination you can take that you will find online. And color bar I want as true. So I'll be writing C bar is equal to true. Execute this, you'll be getting this plot, okay? So in the depth, you can see that most of the values are missing. Like around, you can say 688 values are null values. So that's why you have the continuous plot of yellow color, which means it is missing values. And in this, you have around 177 missing values in the age column. So it is not that much continuous. Embarked and embarked town, you have only 2 missing values. So you have it here, okay? So what you can say that in the between 43, you can probably, if you want to, like you can say between or around 43 or between 43 and 86 rows, you have few null values for the embark and embark town. Next, what we have to do a univariate analysis, okay? So what I want to do is, I want to do the count plot, okay? So this count plot, basically, I want to see that how many count plot, or you can say the distribution plot, okay? So for distribution plot, which function we have used? For distribution plot, we have used dist plot function.
Dist plot.
Right? So dist plot will be done. Basically, this will be showing me the distribution, right? So I can do it for which all column? Whichever column is the having numerical data, right? So how age is distributed, how fare is distributed. I can find it for this. I can find the I can do the dist plot, and rest all I can do the count plot, because they are the kind of categorical data, right? So this is a fixed set of value. This is also a fixed set of value. So I can categorize the data, and then you can get the count plot easily. So to get the count plot, I'll be using here sns.count_plot. And the first column I'll be taking here is the survived column. Okay. So this is the survived column, and data, which data you are taking? So data is equal to Titanic. Okay. Now, where you want to plot, so you want to plot, let's say if I'll be doing this, it will be giving me just a single plot, okay? Category, okay, so this is the categorical data. Survived Y level count. Let me take this. Yes, we are getting the count plots. What I have done, So when I have converted this into the categorical data, it has created a category of 0 and 1. Okay. So don't convert it into the category survived column. Okay. As of now, let's just keep it as the integer 64. And then when we are doing the plotting, so we are getting the plot of how many people did not survive and how many people did survive. Okay. What it has done actually, it has created a survived column with a set of values 0 and 1. Okay. So if you will see this category, when I was checking the type of the survived column after this, it was giving me dot d type. It was giving me that categories that we have created is only for the 0 and 1. Okay. So when I'm plotting it, I'm getting one just single plot. Basically what I want for 0, I want a different plot, and for 1, I want a different plot. So I have to keep it as integer data type only. Okay. So I have converted by default. Now I have converted into the integer data type. So let me do this run again, run it again, and let me check the info. It is now int 64. Okay. So now we are doing the plotting of the categorical data with like how many people did not survive and how many people did survive. I want total 12 plots, 9 plots. Okay. So how I can do that? Using subplots figure comma axis is equal to plt dot subplots, and rows are 3, columns are 3. And then I will be setting the figure size is equal to, let's say, 20, 20. So we have created total 9 plots. Okay. And in this, we are plotting the survived. I have not mentioned the axis. So that has to come by default to the last one. So I want to plot it into the first one. So I'll be writing here, AX is equal to AX of 0, 0. Okay. So it will be doing the plot into the first graph. Similarly, I want to do the count plot of the, let's say, can I do it with the age column? Can I pass here age column, count plot of age column? It gives me this distribution, which is nowhere like, it's not quite understandable. Okay, so let me write here 0, 1. It's not quite understandable, right? So we want a proper distribution of the data. So what you can do using count plot, or we can use the dist plot function for that, sns.dist plot, and this will be giving us both. It will be giving us the histogram plot and KDE plot. So I can write data of age column, and AX is equal to AX of 0, 1. Let's do this. Name data is not defined. Titanic. Okay, so we are getting this, right? Fine. So this is the distribution plot of the age column that we have done for the numerical data, and this is the count plot of the categorical column or categorical data. Okay. So similarly, you have to find the plot of the other column, like you can find the plot of the fair column, or you can find the plot of the sibling, spouse, or sex column, or passenger class. You can find the count plot for that. Okay. And accordingly, you can plot in different graphs. Fine. Now, what we are going to do is, we are going to just do one analysis on the survived column. So let's see how we can do that. So we'll be taking the survived column, and on that we'll be doing some analysis. So let's see. First of all, we are going to find the value count. What is that value count? So if I'll be writing Titanic dot survived, this is going to give me the column. And on that, if I'll be writing value underscore counts, so this is going to give me the value count of how many 0 values you have and how many 1 values you have. Okay, fine. So it is showing me that total 549 values we have which are 0, and total 342 values we have which are 1. So we can get it here that most of the people who boarded the ship, they didn't survive. Okay, fine. 549 people did not survive and 342 people did survive. Okay. You can do the count plot of that using count plot function, so that I will be leaving it up to you. So do the count plot here of only the survived data. Okay. Now next we need to do the histogram plot. How we can do the histogram plot? So histogram plot. To get the histogram plot, we have to access this Titanic.survived column, and then we have .plot.hist. Okay, execute it. You will be getting the histogram plot for the survived column. This is also showing you the same information. This is 0. It means non-survived. It is more than 550 or around 550, and this is around 340 or something, right? So these many people did survive. These many people did not survive. So this is the hist function which gives you the histogram plot for the categorical data. Okay, we have pie plot. So similarly, if you want to get the pie plot, so you can use this, and one function we have is pie.py. Okay, these functions we will be using tomorrow, so make sure you practice it today, and in tomorrow's class we'll be using it. So we'll be doing the analysis first, and then we'll be going for the plotting. Okay, so this will be used tomorrow, so make sure you practice it. So pie plot. Now you are going to get the pie plot for the survived column. Okay, fine. Fine. So when I didn't write this value underscore count. So it was plotting for every row in the survived column, 0, 1, 0, 1, 0, 1, whatever is the value. Now when I did value underscore count, now the whole column is divided into two parts. How many zeros we have, how many 1 we have. And then we are writing pi, so we are getting the pie plot here. So now let's say if you want to see the percentage here, so we have one attribute auto PCT is equal to, I can write here the value percentile 1.1 f, and if you want to show the percentage, you have to write one more percentage. So it shows you that in the percentage area also, like how many percentage of people did not survive. If you want 2 decimal point, you can write here 2. It will be showing you till 2 decimal point. This is nothing. You may skip it. That is not required. You can write any value. That doesn't matter. Okay, but this values matter. So if you be writing 3, it will be giving you till 3 decimal point. Okay, fine. So now next let's do the EDA on passenger class. So we have P class. P class column. So if I want the P class column, I can simply write Titanic dot P class, and that will be giving me the passenger class, right? Passenger class is also having a categorical data, right? So if I'll be writing dot value underscore count, categorical data, when I'm saying, it means it has a fixed set of values 1, 2, and 3, right? Fixed set of values. So I'm referring to that when I'm saying categorical data. Execute it, you'll be getting that how many third class passengers were there, how many first class passengers were there, and how many second class passengers were there. But what exactly I want to group this data based on passenger class and the survived column. Okay, so let's say if I'll be writing here grouping the data based on P class and survived column. Let's see how we can do that. So we'll be using Titanic dot group by. Okay, I want to group by 2 column. One is P class and one is survived column. Okay, execute it. You have got this group by object. Let me do one thing for I in print I. Execute this. Okay, so first class passenger and non-survived passengers. Okay, so that this data you have here, right? So how many first class passenger did not survive? You have this data. Then next, what you have? First class passenger who got survived. So in the first class passenger who did not get survived, the total 80 passengers we have. Okay,
And first class passenger who got survived, total we have 136 passengers. Okay. Next, second class passenger who did not get survived, that is 97 passengers we have. And second class passenger who got survived, we have 87 passengers. Third class passenger who did not get survived, total 372 passengers. And third class passenger who got survived, that is total 119 passengers. Okay. So we have got this data segregated based on passenger class and survived column. Okay. Now what I want to see is, I want to see this survival count in different passenger class, right? So in first class passenger, total count, like in first class passenger. So this is basically data it is showing, the whole data frame. I don't want that. I just want the count. Okay. So I'll be using here survived. I want the survived column and I want the total count. So I'll be writing here count function. That is going to give me in the different passenger class, how many people did survive, how many people did not survive. Okay. So first we have grouped the data. On the group data, we are accessing the survived column. Okay. And from that survived column, we are getting the count. Okay. So let's say if you'll not be writing this, Control X, what you are getting, again, we are getting a series. So let's run this for I in this one. Let's print I. Okay. We are getting this one, 1, 0. And this is just the survived column, right? Only survived column we are getting. You can see here survived column, right? Clear? So if you want to get the count, you can apply the dot count method here. Okay. P class. So you will be getting that for the P class. Again, so in the first class passenger, the count is similar, right? Count will remain similar. Now we have to do the plot for this. Like what I want, first of all, let me plot that how many passengers boarded into the different classes, right? So count plot for P class. We can use SNS.count plot and we can write here P class and data is equal to Titanic. We have this one. So first class passenger, second class passenger, third class passengers were more than or around 500. Okay. Now let's say there is a there are few more attributes we can use hue. Okay. So hue is there. Let's add hue, and inside this I'll be adding the survived column. Okay. So that will be giving me the survival count, survival and non-survival count into the different passenger class, right? So in the first class passenger, how many people did not survive? Around, you can say 50 plus 20, 75, somewhere around 80 or something. And more than 100, around 150 people did survive. In the second class passenger, survival and non-survival were same, but in the third class passenger, non-survival were higher. Next, we have seen the categorical plot, right? So to do the categorical plot, we have seen SNS.cat plot. And inside this, we can pass the different values, right? So for categorical plot, we need two values. One value should be categorical and other value should be the numerical, okay? So I'm using X is equal to P class, okay? Along x-axis, and y is equal to, I'm passing survived column. So this is obviously the survived column is the numerical data, right? And then we have kind is equal to, let's say, I'm getting the box plot. Okay. And data is equal to Titanic. We have got the box plot. Is this the box plot? Let's not do the box plot. Let me do the point. Okay, we have got the point plot. Now, what is this point plot? So in this point plot, we have seen this, like this is the percentage and this is the error bar, okay? This error bar basically shows that if there is some discrepancy in the data, so what may be the maximum value or minimum value. So in the third class passenger, what we are plotting passenger class versus survival rate. Okay, it is the rate, or you can say the probability. Okay, so survival probability, and it is taking, so for, you can say for the first class passenger, the survival rate was around 70%. Okay, maximum. Average it was around 62 or 63, you can say, and minimum it was around 55%. Okay, so if, like, see, this error bar is taken automatically. Okay, so what system considered that if there is some discrepancy in the data, then what may be the maximum value or the minimum value that may affect the data. So this error bar will be coming automatically. Same thing will be shown for the bar plot also. When you will be using bar plot, so this bar plot also gives you the error bar. Okay, and this error bar again shows the same information. Okay, so the maximum survival percentage is 70% around, or the average you can say around 62 or 63, or minimum you can say around 55 or something in the first class passenger. Okay, fine everyone. Similarly for the second class passenger and the third class passenger. Anything else?
Abhishek, can you explain this again?
Oh, so you can see this data, no? So what you can say, so you have plotted survived versus passenger class. So in the every passenger class, what was the survival rate? Okay, and how the survival rate is coming. So if you see the survived data here, okay, so if you see this one is survival rate, right? So you can see most of the people got survived. Okay, so what you can see here, let's say if you will be dividing here around 150 by 87, you'll be getting that survival rate is higher. Okay, fine. Or let's say if you'll be writing around 150 by total, how many people boarded into the first class passenger?
Or is it like this? Total number of first class passengers. In that, how many survived? I mean,
Yes,
136 divided by 136 plus
136
80.
divided by 136 plus 80, you can say.
Yeah.
Okay. Similarly, in the second class passenger, it is around 50%. Survival and non-survival rate is 50%. When you are plotting it, you can see it is coming around 50%, right? And this error bar is the discrepancy. There might be some chances, like when you do the bar plot and line plot, this error bar comes automatically. It will not come in any other plot. But these plots are something, they represent this error bar automatically, that they consider that there may be some discrepancy in the data, right? So accordingly, they will show you the maximum or minimum value that may come if there is some discrepancy in the data happens. Okay. Fine. Okay. So next one, what we have, you can get the Valiant plot also. Okay, so using the categorical plot only, you can get the Valiant plot. So let's use it here. Okay, one more thing you can do, you can add the hue attribute. Okay, hue is equal to, you can write here, let's say for the sex column. Okay, so for the different male and female values, you'll be getting the survival rate. So you can see in the female, if you will be again plotting here, you are plotting survived versus passenger class, right? Actually, you can categorize this data. Let's say if I'll be writing here, hue is equal to survived, not here. Okay, so we have grouped this data. Where was that grouping? We have grouped this data based on passenger class and survived column. Okay. Now let me do one thing. Let me do here sex column. So it is giving 136. No. Passenger class, and have to group this data based on sex and passenger class. And then I have to access the survived column. Let me see. Okay, now it is giving how many female did got survived, and no, 94 females were there and 122 males were there, right? And then we have to get this survived column.
I think in that list you have to add the survived also. C class, sex, and
Yes,
survived.
survived. This one also should be added. And let me write here survived column. So female, first class passenger, female did not survive. This is 3. And female who did survive 91. Okay. In the first class passenger, male who did not survive is 77 and did survive is 45. So from this also we can say that survival rate of the female was around 99%, or you can say 100%. You can find this here. For the female, the survival rate in the first class passenger was around 100%. If we consider the error bar, otherwise it was fine. It was around only 3 female did not survive, right? So it is around 99 or 95%, you can say. Okay. Clear? Similarly, for the second class passengers also, female survival rate was 70 female did got survived compared to 6 female did not survive. Whereas in the male, only 17 male did survive, 91 male did not survive. Okay, so that same we are getting here as well. Okay, so in the male second class passenger, the survival rate was lower. It was around 20%. Okay, fine. Do this one. So we are taking the age column and we are doing the histogram plot for that. Inside the hist function, we have passed the bins attribute to show the variation. Density is equal to true, color is equal to orange, figure size we have taken 12,6, and then we are setting the X level as age. This is showing me the distribution of the age column, how the data is distributed, and this is completely the histogram plot. Okay, fine. And
yeah, can you show the example once more, like Abhishek, can you go? Okay, yeah.
Okay, now let's say if you want the distribution plot, so we can use the dist plot of the Titanic age column, and you already know this, what you will be getting it here. Okay, so you'll be getting KD plot and the histogram plot, both, mix of both. Okay, now to get only the KD, you know what you can do, you can set hist is equal to false, or to get only the hist, you can set KD is equal to false. Okay, but let's say if you want to do the categorical analysis based on the column, let's say you want to plot age versus the male or female data. Okay, so what you can do here is SNS dot cat plot and cat plot, and here we'll be writing X is equal to, let's say I'll be using sex column, and Y is equal to, I'll be using age column. Okay, data is equal to Titanic, and I'm going to get the kind is equal to, I'll be plotting, let's say box plot. Okay, so let's see what plot I'm getting. So if you'll see male and female distribution of the data, what we can understand from this data is that, so this is 25 percentile and this is 75 percentile. Okay, and you have some data or some people who were outliers in the male, like they were more than 60 or 70 years of age. Okay, but most of the data lies in this range. Okay, 25 percentile, 75 percentile, this is the mean value. Okay, and now if you'll see this, so the average age range was between, you can say 20 to 40. Okay, whereas in the case of female, it was between 19 to 38 or something. Okay, and the average age for the male was around 30, for the female it was around 25 or 28 or something. Okay, so you can get this plot using the box plot, or this information from the box plot. Let's say if you want to see this same information of the based on sex column, you want to get the distribution of the different passenger class, right? So you can set the Q is equal to P class, and you'll be getting this for the different passenger class. And you can easily see that in the first class passenger, male were in the range of 30 to 50. The outliers were coming from the second and third class passengers into the male, and in the female also second and third class passengers. Okay, in the first class passengers we were not having outliers. Okay, and the average age was for the first class passenger, male was around 40, for second class passenger 30, and for third class passengers was around 22 or 25. Whereas in the third class female passengers, it was around 35, 30 for second class, and around, you can say, 18 or something for 20 for the third class passengers in the female. Okay, fine. So if you want to get this plot separately, so you can use, instead of using hue, you can use call attribute. Okay, instead of hue, you can get the call attribute, and that will be giving you a different plot for different passenger classes. Okay, passenger class 1, 2, and 3. Okay, so that's it. Next, what we have. Yeah, so I think you can get the different plot. Now I have done it into the sheet that I'll be providing to you. So this is the swarm plot we are getting. And if you will be adding one more attribute here, let's say what I am doing here. I'm plotting P class versus age. Let's say if I'll be writing here, Q is equal to so we are getting this plot. So it is giving you how many, like in the third class passenger, most of the passengers were male. Okay. And female numbers were higher into the first class passenger, basically, we can say. Okay.